following measurements is the most reasonable estimate for the standard ceiling height of a residential room? When tackling metric estimation questions, it helps us separate our options into two main categories: small scale units and large scale units. Millimeters and centimeters are perfect for precise small objects like hardware, insects, or stationary items, while meters and kilometers, on the other hand, are meant for structural and geographical distances, such as the height of a room or the path of a long travel route. Keeping this distinction in mind, we can immediately eliminate two of our answer choices. But let's take a look at each answer choice, starting with answer A, 2 and 5 tenths of a millimeter. Now, this measurement is extremely small. To put this in perspective, it is roughly the thickness of just two pennies stacked together. So we can safely rule this one out and take a look at answer choice B, 2 and 5 tenths of a centimeter. A quick scale check reminds us that this is about 1 inch, which is the width of an adult thumb. A room with a ceiling height of 2 and 5 tenths of a centimeter would be impossible for any human or pet. This is meant for small desktop trinkets and not living spaces. Let's take a look at answer choice C, 2 and 5 tenths of a meter. 1 meter is about 100 centimeters. All right. So, and typical ceiling height is between 8 and 9 feet. So this would make option C our most reasonable estimate out of the three options that we've talked about so far. But let's take a look at option D and then we can pivot back to option C. 2 and 5 tenths of a kilometer. Now this represents a massive scale. Now, just a reminder, 2 and 5 tenths of a kilometer is about 1 and 5 tenths of a mile long, which is actually higher than many mountain peaks. If a ceiling were truly this high, clouds would likely form right inside your living room. This unit is strictly for geographical travel distances. So, to summarize, 2 and 5 tenths of a millimeter is as thin as two pennies. 2 and 5 tenths of a centimeter is the width of a thumb, and 2 and 5 tenths of a kilometer matches the altitude of a mountain. By analyzing real world scales, we can easily see why option C would be our most logically correct answer.